Accuracy,
speed, robustness,
speed, robustness,
scalability, interpretability.
scalability, interpretability. So accuracy deals with the capability of the classifier or predictor for generating the good results or correct results, accurate results. Whereas what next? Robustness. Robustness is the capability of the classifier while in the presence of the noisy data. So how the classifier is handling the noise data. How classifier produces results in case of noisy data. And the third one is interpretability. Indicates the level of understanding what we get from the classification and prediction results. And next, scalability. So how the classifier is efficient in case of large amounts of data. So even though it is efficient for small data sets, so what if the data set is too large? Even though in that case also the classifier is able to handle efficiently, then we can call it as efficient classifier or efficient predictor. And next, coming to the speed, it includes, that means it indicates the what speed in the sense computational cost. So that should be as minimum as possible. So out of many classifiers we're having, if a particular classifier is having less computational cost for a particular data set, that classifier can be selected to make the model, to make predictions on the data set. So these are about the issues regarding classification and prediction. And let's move to the decision trees. So we are having different types of classifiers. What are those? Decision trees, KNN, navigation, and other ANN, artificial neural network classifiers we are having. And next,
Random forest.
random forest. So like that, we are having several classifiers. So now yesterday we have seen an introduction about decision trees, right? Wait for a while, like it's loading. So decision trees, as the name itself indicates, the decision trees are tree-like structure. The decision trees are tree-like structure. As usual, we already know about the trees. The topic of trees are covered in data structures in your second year or third year, I think. So here, as shown, in the figure here, this is a root node, and these are the internal nodes, and these are the leaf nodes. And every root node or internal node is with some test, having some test, and the result of test is indicated on the branches of the tree, and based on the result only, the data set is partitioned accordingly. And the process is repeated like this, and at the last we will get the class labels. So the class labels are indicated with the oval shape, whereas the internal and root nodes are indicated with the rectangular shape. And here is an example we have considered to understand more about decision trees. And here is a data set of electronic company consisting of customer A's income, student, whether he is student or not, like his credit rating, and whether he buys a computer or not. So this is what kind of data set? Binary class or multi-class? This is what kind of data set?
Binary.
Binary class. It includes only two classes. One is S and another one is no. So like this here, this is the equivalent representation of the decision tree classifier, which is constructed from this data set only. So let us understand before going for the process of decision tree induction. Induction in the sense training the or learning the decision tree. So before moving to the process of decision tree induction, let's deal with what is actually the decision tree, how it is constructed, what are the constraints, and what are the issues regarding the decision tree. So here, out of all attributes, here the first and foremost step is the attribute selection process. So here the first step is attribute selection process. So first we need to select the best attribute, as a root. So for a tree, we need to have a root. So for this, we need to first select the attribute. Which attribute we need to take as the root attribute. So for that, we having separate methods for selecting the attribute at every stage as a root attribute. We are having some other methods which are covered in the latter part of the presentation, maybe today or for the next class. So here is the attribute selection process is there, and based on that process, based on the result obtained, we need to select one of the attribute as the root attribute. Okay, some process is there behind this, and after that, based on the values of the attribute. So how many values A's have? Just go through the data set. A's having how many values? How many kinds of values? How many in the sense there are 14 values for A's. I'm not asking that. I'm asking is how many types of values A's have?
Three.
Three types. One is
Youth, middle
youth,
age, senior.
middle age, senior. So
Senior.
A's have three values. So each value, for each value, as discussed earlier, for each value, we need to have a branch from that tree. So here is a test. So here is after selecting the particular attribute, here we have selected A's as the root, and this process is separate. We will discuss this later. So based on the values of the root attribute, we need to have a test here, right? So if age is youth, we need to go this way. And if age is middle age or if age is senior, that is the case. This is already explained yesterday. So here we are having three values for the age. So simultaneously, we are having three outcomes from this root. That means which indicates that we are having three branches from this root node. So here the name of the first branch is youth. Why? Because the value of the A's, each value of the A's is reflected on the branch itself. Each value of the A's is reflected on the branch itself. So this branch is youth branch, and this is middle age, and this is senior. So after that, what happened here at this stage? For suppose consider this is a step one or level one or phase one, whatever for our understanding only. So here at this initial stage or initial step, what we need to do is here we are having the training data D. We are having the training set. For example, let us assume that this is all your training set. Testing set is separate, and this is all our training set D. So here we are having in the, for example, this is level 1 and this is level 2. In level 1, we are having all the data with us. The entire data is with us in level 1. Whereas in case of level 2, the data set is divided into three partitions. The data set is divided into three partitions based on the result of the test. So here is D1, here is D2, and here is D3. The total data set is divided into three partitions. How it is divided? So based on the result. So D1 consisting of all the data elements whose age belongs to youth. Similarly, D2 partition consisting of the data elements whose age belongs to middle age. Similarly, D3 partition consisting of the data elements whose age belongs to senior. So for this example, since this is a very small example, you can easily analyze, I think. So what we are already having some serial numbers for each and every tuple of the data set. So just let's go through the data set and tell me what is the tuple number which fall under D1 partition. Just for your understanding, just tell me, go through the data set and what are the list of tuples fall under D1 partition. You can indicate the tuple with the tuple number, that is RID.
1, 2,
1, 2,
8, 9,
8,
11.
9, 11. So how we get this? Because if you observe the tuples 1, 2, 8, this is 1, 2, 8, 9, 11. So in all the cases or in all the tuples, the age value is youth. So that's a good answer. That's a great answer actually. So So all the tuples numbered with 1, 2, 8, 9, 11 are fall under the partition 1. That means under D1 partition. Whereas under D2, what are all the tuples fall under D2 partition?
7, 12, 13.
3,
7,
7,
12,
next
13.
12, 13. Very good. And similarly, coming to the D3 partition. Here I can write. So what are the leftover elements, leftover tuples?
4, 5, 6,
4,
14.
5, 6,
14.
I think 10,
10,
10
10,
also, right?
14.
Yes, yes, yes. 10, 14. So why? Because for the tuples 4, 5, 6, 10, 14, the age value is senior. So this is the case up to the level 2. So what we have done till now in the level 1, we have selected a attribute from the attribute list. The attribute list includes attribute age, income, student credit rating, etc. etc. So from all the attribute list, we need to select one based on some process, some attribute selection process. Okay, in the step 1, and after that, we need to partition the data based on the number of values for that selected attribute. So since we have in this particular example, we are having 3 values for the attribute. So that the data set is partitioned into 3 partitions, 3 splits. We can also call it as split. Remember this terminology also. This terminology is also very important in case of decision trees. Split or partition. And after that, next here, now we are in the stage 2. We are at this stage. Now what? Here we have selected student as the, see, this is actually the tree, and within this tree here is a subtree. Let me change this. So here is a subtree, and again here is another subtree. So the same process is repeated for each and every subtree until you get the leaf node. So here is the same process. Again, assume that this is the root node, right? Actually, this is the internal node for the whole tree. But if we consider this is a particular, this is particularly a separate tree, now this become the student become the root node. So again, the same process. How to find out the attribute, particular attribute? Why should I mention student here? Why can't I mention credit rating, or why can't I mention income, or why can't I mention age again? Why? Because the first rule is whatever attribute we have selected earlier, that should be removed first from the list of attributes. So our attribute list initially consisting of the attributes like this. Here the class attribute is removed. Why? Because it shouldn't be, that is for classification. We shouldn't be considered in the training process. So this is removed by default. And next we need to remove each and every attribute which is selected as the root attribute at every level. So initially we have included age, but now once the age is selected as the root attribute, we need to remove this from the list of attributes. Now we only have these 3 attributes as the in the list of attributes. So out of these 3, income, student, credit rating, we have selected student as the root, student attribute as the root for the next level. Why student? Why not income, or why not credit rating? That is also by following the attribute selection process. The same thing is repeated for every subtree. So that is also by following the attribute selection process. We have some process and we have different methods for that. We will discuss in later class. So here student is selected. Okay. So how many values are there? That means how many types of values we're having for student? Again,
2 values. Yes.
again 2 values for the student. One is S and one is no. So obviously, what is the next step? Again, how many splits we are having here?
2 splits.
2 splits. So here D1 is again partitioned into further. D1 is further partitioned into two splits. That is, for example, say D11, D12. So what are the elements fall under D11? What are the elements in the sense? What are the observations we are having under D1? So what is the condition actually? That should be D1. So in D1 in D1 only we are considering D11, D12. We shouldn't go for the remaining tuples. We need to consider only D1. So first, what are the tuples in D1? These are the tuples in D1. So out of these, how many tuples fall under D11 and how many in the sense, what are the tuples? What are the number of numbers, respect to RIDs? What are the particular tuples fall under D11 and what are the particular tuples fall under D12? Coming to D11, what is the condition first?
Student
The
1.
value of the student should be
No.
no. So if at all out of 1 to 8, 9, 11, if at all the value of the student should be no, those tuples comes under D11. So just go through the data set and tell me what are the tuples comes under D11?
1, 2, 8.
1, 2, 8. Yes. So the leftover tuples 9,
11.
11. Yes. So here 1, 2, 8 comes under D11, whereas only 9, 11 comes under D12. So again, what happened here in the next level? We are again we are again making a split of the data or making a partition. We are again making the partition or split here. So as a result, uh, I mean, some other branches are generated. And again here at this stage, the same thing is repeated for the other branches also. So what happens are again here, again we need to go through the database or data set. If at all the attributes are there, we can mention that. If at all the attribute list is empty, we can come for the conclusion. So here if you observe, the age is already used, student is already used, and credit rating is used parallelly. And here this particular example does not consider income. Maybe this attribute, because this is a simple example, why they are excluding income in the maybe that may be removed as a process of pre-processing. Why? Because in pre-processing step we are having relevance analysis. So in relevance analysis, we are having we can remove the irrelevant attribute. Maybe for the task, the income is irrelevant. That's why they are not considered income as the one of the attribute in the attribute selection in the list of attributes. So income is excluded here. So here, student is already used, age is used, credit rating is already used. Now the attribute list is empty. So once the attribute list is empty, we can come for the conclusion. So now we need to label the partition. Label the data fall under partition D11. Similarly, we need to label the data fall under partition D12. Now, how to label this? How to label this? So the labeling is done based on the majority labels of the partition. So what are the tuples comes under D11? Number 1, number 2, and number 8, right? So what is the majority labeling? What is the label of 1? What is the label of 1?
No.
Label of 1 is no. And next label of 2?
No.
Again no. Label of 8?
No.
No. That means what? The majority, that means almost all the data elements are belonging to the class? No. So we can conclude that here the label is no. Right? The same thing, let's check for this D12. What are the RIDs of D12? 9 and 11. So what are the labels for 9 and 11?
Yes.
Label 9 is yes. Label 11 is also
Yes.
yes. So here also the majority labeling is yes. We can mention here yes. So in this way, we can generate the decision tree. In this way, this is the learning process. In this way, we can generate the decision tree. For example, here, out of for D11, out of 1 to 8, fortunately, in this example, the labels for the tuples 1 to 8 are no itself, right? For example, if there instead of two no's, if for example there are two no classes and one yes class for this data partition, then what label we need to select finally?
No.
No. Why? Because we are telling that we need to select the majority labeling. If at all labels are belonging to the same class, then there is no issue. We can directly choose that class which we have done just now. So if at all it is not the case, then what to do? We need to take the majority label of the tuples comes under the partition. That is the case. And here we need to discuss about one more thing. Here, if you observe, uh, here if you observe this here in the second branch, that is the D2 partition, we are not generating any subtree. What is that second branch? Middle is. So if you observe here, we are not generating any subtree. Why we are not generating? Uh, why we are not generating any subtree?
Class label of middle aged is S.
Yes, if you consider the middle is tuples. What are the tuples under middle is? D2. Here it is. 3, 7 and 12 and 13. So if you consider that every tuple falls under the same label. So no need to again branching out on the middle is. So in this way, there are some other constraints, and those constraints are explained with an algorithm, decision tree algorithm. So here, what we have understand till now, here we have an attribute. That attribute list includes all the attributes belonging to the dataset, all the relevant attributes belonging to the dataset, excluding the class attribute. And after that, we are having attribute selection process. And by using that attribute selection process, at every stage, at every iteration, we need to select the best attribute that make the best partition. And after selecting that, that should be removed from the list of all attributes. And after that, we need to select, we need to go for the based on the values of the attributes. Based on the values of the selected attribute, you need to make data partitions. That means you need to branch the data further. So after that, at the next iteration, again the process is repeated, selecting the attribute as a root attribute, and again based on the values, partitioning the data further, etc., etc. And here we need to discuss about one more thing. One last thing we need to discuss about this, about the decision tree, that is purity of the partition. That is purity of the partition. I know this is a little clumsy. The screen is little clumsy, but if you follow from the beginning, you may not get confused. If at all you look into the screen by not following the class, you may get confused. So purity. So here is the most important concept of the decision tree: purity or quality of the split or partition. So what is meant by purity of partition? Here the two terminologies we need to know about: pure partition and impure partition. What is that pure partition? What is that impure partition actually? So here, if you consider here, if you consider the labeling process of this subtree, the labeling process of this tree, if you consider here under D11, we are having what three observations, and fortunately, all the three belongs to the same class, that is no class. So if at all the elements of the partition are belonging to the same class, that partition or that split is referred as a pure partition. That is a pure split. So here also this is a pure partition. Why? Because all the elements of the partition are belonging to the same class. If at all, if you consider this example, what is this example? If at all, majority of the elements of the partition belonging to one class and one or more elements belonging to another class. So that is actually impure partition. That is actually impure partition. Since we are having data set with only 14 elements, it is very easy for us to identify what is the pure partition, whether the partition is pure or by just going through the data set. But in real-time examples, the data set size may be in gigabytes or terabytes. Some millions of rows are there for the data set. So it is not possible to go through the entire data set and check line by line and check whether the partition is pure or not. So there is some strategy for doing that. Just I'm introducing the terminology of pure partition and unpure partition. What is the purity of the partition, etc. I think hope you understand this topic, right? So here this come to the some theoretical aspect, theoretical concern. Here coming to the decision tree induction. Decision tree induction is the learning of decision trees from class labeled training tuples. So what is the process of induction? Induction in the sense a process of constructing the model. That means learning the decision tree. Okay, decision tree algorithms, we're having famous decision tree algorithms, ID3, C4.5 and CART. So next, coming to the top-down approach, decision tree follows some top-down approach. It starts with the training set of tuples. Just while I'm reading, you just try to recollect what we have discussed earlier. You can you should try to recollect and try to map that to this theory part here, so that you in the exams you can able to deliver easily, comfortably. So top-down approach starts with the training set of tuples and their associated class labels. We know that, right? We are having at the beginning, we are having the training set. This is D in our example, along with the associated class label. The training set is recursively partitioned. Did you understand this? The training set is recursively partitioned into small subsets as the tree is being built. Did you perform this or not? Yes, yes or no?
Yes, ma'am.
Yes, did you go? We go through this, right? This recursive partition. Why? Because initially D is there and later D1, D2, D3 is there. And later again, we have divided this into D11, D12, and this is also having some divisions. So this is called recursive partitioning. Again and again, we are further partitioning until we get the class label, equivalent class label, right? And here is the algorithm, and just follow the algorithm carefully. Why? Because in the exam, if at all the algorithm is present in your textbook, you need to mention that for scoring the good marks. Okay, this is the process. This is the same. This algorithm explains the same process which we have discussed till now regarding the decision tree induction. Induction in the sense learning of the decision tree. So one more thing I have forget to tell. So after construction of the decision tree, so we have constructed this by following the previously discussed procedure. So once we have constructed in the sense, the learning phase of the decision tree is completed. So we are ready with the model. We are ready with the what model? Decision tree. So we are ready with the decision tree model. So once the model is ready, how to check whether this is a good model or not? What is the supported data set we are having? So we are constructing the model with the training data, which is D in our example. We are constructing the model with the training data, which is D in our example. So we have constructed a model. This is our model actually. So once the model is constructed, how to check the model? How to check whether we are what the generated model is correct or not? How to check that? Is there any way? Is there any way to check?
డేటా సెట్‌లో ఏమైనా ర్యాండమ్ టపుల్స్ తీసుకొని వాటి క్లాస్ లేబుల్స్‌తో చెక్ చేయొచ్చు మ్యామ్.
దాన్నే ఏమంటారు? దట్ మీన్స్ ఆ ర్యాండమ్ సెట్ ఆఫ్ టపుల్స్ ని ఏమంటారు? There is a specific name for that. What you said is exactly right. What?
Observation.
Observations, okay. The group of observations which are used for testing the model is referred as what? You are very near to.
Classification.
Those are test data sets. Those are test data sets. We are having, along with training data set, we are having a testing data set also, right? So the process, what is the, how to generate the testing data in the sense? The same thing, what you have told now. So test data is generated by randomly picking some observations from the data set, which are not used for training the model. So which are not used for training the model, those observations we need to pick up and we need to remove the labels of the observations and we need to apply each and everything here. So if at all my observation is like this, the age is, if at all I have an test observation or test element like this, youth, and next here is my observation. So what is the label for this? So if at all the age is youth, you can go in this way. And next, the next value is yes. That means student here. So what is the final label?
Yes.
Yes,
Yes.
ma'am.
Yes. So this may be the correct answer or this may be the right answer. Why? Why? Because these are the not actual labels. These are the predicted labels. So this is a test set. This is a test set. One of the observations from the test set. And by applying the model, we get this label for the test set. But maybe the actual label may be yes or actual label may be no. That is some other case. Based on that only we need to generate the accuracy based on that value, and again thereby we need to declare whether the classifier is a good classifier or not, efficient classifier or not. So that is the second case. Here we are dealing with the process of prediction. So how to predict in the sense? In this way, based on the test set. So this is the class for this tuple and this is a predicted class using the generated model. Actually, we don't know the label of this initially, but we are already have a constructed model. So with this model, we labeled it as some S. So now having some other observation from the test set, and this observation is, so what is the label?
No, ma'am.
No. Why? Because if age is senior, we can go in this way, and since it is fair, the label is no. This is also the predicted label. So these are all generated labels of prediction, not the exact label. If at all, the exact label for this particular observation is also as it's a perfect classifier. This observation is also the label of this actual label is also no. Then this is a perfect classifier like this. Now coming to the this is about the testing of the decision tree. Now coming to the algorithm, just I'm read out the algorithm line by line, and I know that the process of decision tree induction you already know. Just I am mapping the theoretical part with the knowledge what you gain just now. Okay, listen carefully. This is very important. If you understand this, you can able to easily represent in the exam. No need to remember or no need to by heart. So here is the algorithm for the generation of the decision tree, and the name of the algorithm is generate decision tree. And here as an input, we need to take the data, training data D. which is a set of training tuples and their associated class labels. We already know this because every training data should include along with the labels. But whereas the case of test data, it should be excluded for the labels. That is the other case. And next, attribute list. So we need to have the list of all attributes, right? And next, attribute selection method. I told you, right? There is some attribute selection method to select what attribute we need to take as a root attribute. That is the attribute selection method. We need to take, we need to select that because we are having different attribute selection methods. We are having information gain, gain ratio, Gini index, like that. We are having different types of attribute selection methods. So out of all, what attribute selection method we need to consider? So after that, the output is a decision tree, constructed decision tree. And coming to the process, here initially create a node n. Okay, if tuples in D are all of the same class C, then return n as the leaf node labeled with the class Ci. If suppose, for example, here in the data set, all the tuples are yes only, then is there any need for going further? That means if all the tuples of the data set are belonging to the same class, no need to go further. We can stop there, right? So that is the case here. So if tuples in D are all of the same class, then return n as the leaf node. So that is the root node and that is the leaf node. So label it with the class C. So what class is there common to all the elements? That class should be present as a label, and we can exit the process. We can terminate the loop. That is the case. And here another case is there. If attribute list is empty. So I have discussed here, right? I have discussed here. So if you go for the further partition, if at all there are no attribute list, we can stop there and we can add the leaf node, right? So if the attribute list is empty, then return n as the leaf node. So then that node become the leaf node with the majority p. So what is the label of the leaf node? We have already discussed. So what is the majority class in this D11 partition? That is only the label for this leaf node. And coming to the step 6, apply attribute selection method. So these are all the what we have discussed. These are all the termination conditions. If at all this is not the case, so initially what to do? This is the initial process. Initially what to do? First we need to apply the attribute selection method. Attribute selection method. So apply attribute selection method. So initially we have discussed about the some terminating conditions we have discussed till 5. Now we are entering into the actual process. So apply attribute selection method. So for that attribute selection method, we need to send? We need to send the entire data set and we need to send the list of all attributes. So after doing some process, we need to find out the best splitting criteria. Splitting criteria in the sense, the best attribute. Best attribute is also referred as, just remember this terminology. Remember this terminology, splitting criterion. Splitting criterion indicates the best attribute. So we need to select the best attribute from attribute selection method. So after that, after selecting the best attribute, label node n with the splitting criterion. We need to label the, just wait. We need to label this. We need to label this. We need to label this with that selected attribute, which is also called as splitting criterion. Here, what is the splitting criterion? Age is the splitting criterion. Whereas in this case, student and credit rating are the splitting criterion. So for this subtree, student is the splitting criterion, and for this credit rating are the splitting criterion. Just simple. Splitting criterion is nothing but a selected attribute. So label node n with the splitting criterion. Okay. If splitting attribute is discrete valued, discrete in the sense categorical. Yes, we are having all categorical values. So multi-way splitting allowed, then multi-way in the sense more than 2 splits are allowed. That means the values are more than 2. We are having more than 2 values. Next, what to do after that? We need to remove the splitting attribute from the attribute list. I already told you, right? Once the age is selected, we need to remove the age from the list of all attributes. That means we need to update the attribute list. We already know this, right? And this is actually the iterative process. So for each outcome J of the splitting criterion, so we are having three outcomes, right? One, two, three. So for each outcome we are having, so partition the tuples and grow subtrees from each partition. We already know this, right? We need for each outcome we need to partition the tuples. That's why only we are getting D1, D2, D3. So if at all the particular partition is empty, then what? If at all particular partition is empty, then attach a leaf labeled with the majority class in D to node N. If at all you get particular empty partition, then we need to we need to attach the majority class labels to that, or else attach the node written by the generate decision tree. Or else what to do? Again here we need to call the generate decision tree function. What is the generate decision tree? This is the generate decision tree. That means the entire process we need to follow up for each phase, follow up for each for generating the each subtree. So this process is repeated until we get the labels for all partitions. So this is the process of constructing the decision tree. So I'm going to close this class now. I'm before closing. I just want to make two announcements. Just wait for 2 minutes.